Assalamualaikum warahmatullahi wabarakatuh. My name is Putra Nudenish bin Rizwari from Group 4, which is Section 6. This is our group member, which is Muhammad Izzat bin Omar, Sufia binti Ahmad Sofi, Ahmad Hari Akmal bin Ahmad Badruddin. So for today's presentation, we're going to present about assignment set 2. So question 1, which is give question 1a, which is given an output response yt of a system yt equal to x power 2t exponent negative axt. So determine the homogeneity of the system. First of all, determine the homogeneity. We must find the function. The function is homogeneous or non-homogeneous. So as we know, homogeneity system is a system which produce an output yt for an input of xt. So we must determine which is y1t and y2t is similar or not to determine the homogeneity. So the answer for the question 1a is first of all we are creating a block system to view it more clearly, which is xt, ht, and yt according the order. So first step is multiply input with k. So the input xt uh, according the which is xt, and then we multiply by k, and then the xt will become kxt. After that, kxt substitute to the ht substitute to the ht, and then the output will become y1t equal x power 2 t exponent negative akxt. That's for the first function. As we know, multiply input with k. We know it is input. So the input, if multiply input, so the multiply operation k must be before the ht before the ht. So for the second step, multiply output with k. So we know it is multiply output. So the operation of the multiply k must be after ht. So the step for this step, xt substitute to the ht, so it become yt equal to x power 2 t exponent negative axt. After that, multiply with k. So the whole function will multiply with the k. So y2t will become k y2t equal to kx power 2 t exponent negative axt. For the third step, compare y1t with y2t to determine the function of the question is homogeneous or non-homogeneous. So compare y1t with y2t. From the above, we know that y1t equal to x power 2t exponent negative akxt, and y2t equal to kx2t exponent power negative axt. So the conclusion is y1t is not same with y2t. Both functions are not similar. So we know that the function yt is non-homogeneous function.
Assalamualaikum and hello. My name is Muhammad Izzat, and today I'm going to present about question number B1. Okay, for question B1, test the stability of this following system with assumption of k is bigger than 2. Okay, so this is the equation for this question, and then the information that we need to know is, in order to determine whether the system is stable or not stable, we have to find the output first. Okay, so we can find output in terms of graph, and then if the output is bounded, then we can consider the system is stable. And if the output is not bounded, it is not stable. So that is the very important information that all of you need to keep in your mind. Okay, so for the solution, in the question it states that k is bigger than 0, so we can let k is equal to 1, and then if we substitute the value of k into the equation, then we get the new equation, which is exponential to the power of negative t ut. Okay, so this is our new equation. Okay, then we need to draw a graph, two graphs, which is ut graph and exponential graph. And for ut graph, it look like this with 1, and then if the and for the exponential graph, it look like this. Okay, then we need to multiply both of the graph. Okay, if we look at this, from negative infinity to 0 is 0, no line, which means 0 times 1 is 0, so the output here is 0. And if we look from 0 to positive infinity, there is a value 1, so 1 times 1 is 1. So this is the output and the final and the last graph. Okay, so based on this graph, look here, the output is bounded to each other. Okay, so based on the previous information that I already explained to you guys, if the output is bounded, it is the stable system. So we can write for the conclusion, the output is bounded, thus it is stable system. Okay, so this is the solution to solve this question. First is we need to substitute the value of k, and then step 2, we draw the graph, both graph, ut graph and exponential graph, and we multiply it, and we determine whether the output is bounded or not. If bounded, it's stable system, and if not, it's not a stable system. Okay, so that's all.